Hi, everyone, and thanks for having me here. My name is Francesco Raimondi, and the reason I'm here today and the general idea behind this presentation is to talk about ransomware attacks life cycles with a tool that me and my colleagues have developed internally at Fractal. So we will go through a quick discussion on purple teaming. So what it actually is, what are the benefits of conducting purple teaming exercises, and how they fit into the context of emulating ransomware attacks. We'll explain the reasons why we're focusing on ransomware threat groups. We'll look at some of the statistics on ransomware attacks and how they have evolved during the course of the years. We'll then discuss the motivations and needs that brought us to find a solution on how to efficiently emulate ransomware attacks lifecycle, and how we went through the process of gathering various TTPs for known threat groups from various researches. Then we'll dive deep into the technical details of the tool itself. So how it was built, some of the difficulties and challenges that we faced during the development process and how we tackled those, the functionalities that we have implemented into it. And then, of course, we'll look at some examples of a few of the number of features that the tool itself provides. Just before closing and wrapping up, we'll have a look at the results of the tests that we have conducted for AV and EDR solutions that we encountered during our engagements. We'll discuss the techniques that we have executed and how these tools fared against what we ran, what was detected and what was not. And then, of course, in the end, we will dedicate some time for questions and comments. So, a few words about me. I'm a cybersecurity consultant, currently working as a cloud security architect and purple teamer at Fractal. I've been always interested in both the offensive side of cyber and the cloud security as well. And I've been trying to join those two fields together, exploring different ways of applying offensive stuff to the cloud. So my previous working experiences and the current one, as a matter of fact, have always been a mix of both red teaming and cloud security. I get a bunch of certifications, both on the offensive side of cybersecurity, as well as on the major cloud service providers. And the rest of my free time goes to the music. I'm a drummer, so whenever I'm not chasing some new certification, I spend the rest of my time giving and taking drum lessons and recording drum parts for various musical projects. So as I just said, one of the areas I spend most of my time and I focus on is purple teaming exercises, specifically on the offensive side of it. And just to give an idea of what I mean when I talk about purple teaming, the main concept is to have a close collaboration between the blue and the red team, especially when we have planned exercises and joint workshops. And if we take into consideration the various functions and categories of the cybersecurity activities described in the NIST cybersecurity framework. So we have identify, protect, detect, respond, and recover. And in purple teaming exercises, the focus is on the detect and respond phases of the NIST cybersecurity framework. So usually companies spend a lot of time and invest a lot of resources into trying to build this detection and respond capabilities, but then they do not test or assess them. So with purple teaming, it becomes possible to continuously assess and verify an organization capability of detecting and responding to security incidents, which are the areas where there is probably most room for improvements, but also where it is possible to efficiently disrupt potential cyber attacks. So overall, this is definitely one of the things that can provide huge benefits to an organization, especially if there is a strong sense of collaboration and communication between both the red and the blue team, but also the organization itself. If we compare traditional red teaming exercises with purple teaming, in purple teaming, there is a lot more focus into trying to create a sense of collaboration and trust between all the parties involved, which in the end provides the most benefits for basically everyone, as everybody learns something. So why focusing on ransomware attacks? Well, there are several reasons why this is so important nowadays. First of all, as I'm sure everybody knows, ransomware is a very lucrative business for cyber criminals. The impact of ransomware attacks can be huge, and this is true both for financial impact, but also in terms of companies' reputations and business continuity. And the number of ransomware attacks has increased exponentially during the course of the years. And this is especially true if we consider what I just said in terms of financial gains for cyber criminals, because of course, all these attackers and threat groups are always more motivated if they see that companies are willing to pay the ransom in order to get back access to their data. If we look at some of the statistics, we can definitely see a huge growth in terms of financial loss for companies due to ransomware attacks, but also in the number of ransomware attacks that are conducted against companies. So overall, the business of this type of attacks is booming, and it's definitely bound to increase over the years. We also need to take into consideration here that the COVID situation has most likely played a major role for the increase of all these numbers and for the increase of the number of cyber attacks in general, of course. There is a great article from the folks at purplesec.us that focuses specifically on the increase of damages done by ransomware attacks over the course of the years. We see that in 2020, the estimated amount of damage done globally by ransomware attacks has been around $20 billion, whereas it has been estimated to be at around $8 billion in 2018. Of course, these are just indicative numbers. I'm sure the actual numbers are way higher, but still it shows how much this value has increased in just over the course of 2 years. We also see that just during the last quarter of 2020, the average amount of days of downtime has been around 21. And during the same time span, the average amount of money paid for a ransom by companies has been around $155,000. And this is according to a report done by CobraStrike that focuses specifically on the extortion data of ransomware attacks. And as I mentioned, the number of ransomware attacks conducted against companies has increased exponentially. So we see recording an increase as high as 365% in 2019 compared to previous years, according to the NISA. And again, these are just statistics and numbers based on what has been detected and reported. So the reality is that all these numbers are unfortunately way, way higher. If we take into consideration, for example, advanced persistent threats that go unnoticed for several years, and which are definitely the ones that pose the highest risk for organizations, it's easy to imagine how many of these attacks are going on right now completely undetected by the victims. So how companies can or do protect themselves? Well, as everything in security, a multi-layer approach is usually the best. So we have the first line of defense, where we have defensive technologies put in place to somehow prevent and protect from ransomware attacks. We have the development of capabilities to identify ransomware TTPs when they are happening. And then we have the development of capabilities to respond to those TTPs and hopefully recover from the impact caused by those. And these first 3 layers are where we usually see things like common anti-malware, AVs and EDR solutions, threat intelligence teams, blue teams, SOC CMs, and so on. And then finally, we have the emulation of ransomware attacks lifecycle in the context of purple teaming exercises. And the aim here is on the detect and respond phases of the NIST cybersecurity framework, as I mentioned before. And in a way, with purple teaming exercises, where we emulate as much as possible what a real life attacker is doing, we can kind of join together all these single pieces and components to make sure that they work in sync to protect an organization. And this is actually true for every sort of threat or attack simulation, not just ransomware specific ones. So the main idea behind the emulation of ransomware attacks inside the context of purple teaming exercises is that ransomware attackers share common patterns and behaviors and TTPs, and we can reuse these TTPs in the context of purple teaming exercises to emulate specific threat actors or groups. So at some point, we found ourselves in a situation where we were basically repeating over and over the same TTPs to emulate a specific threat group that was targeting a specific business in a specific sector or industries. So what we then realized was that we would have benefit to automate the execution of all these TTPs in order to focus on the emulation of specific threat actors. So what we then decided to do in order to automate the emulation was to develop a tool, which we then named Fransom, which helps us to do exactly that. So emulate typical ransomware attackers' patterns and behaviors throughout the entire attack's life cycle. So Fransom is a tool that is intended to be run from the point of view of a compromise standpoint. So we are talking about the assumed breach scenario here. And the aim is to measure and assess the effectiveness of existing defensive technologies inside an organization. But before diving into the detail of the tool itself, I want to briefly discuss what are some of these TTPs that I'm talking about and that we see in ransomware attacks. So over the course of the years, several authorities and organizations have done extensive researches on various threat groups and attackers, and those have been extremely valuable for the InfoSec world, especially if we consider all the researches and work that have been done for the various advanced persistent threat groups and nation-state sponsored cyber attacks. So we have used those researches as a basis for our development to try to lay out commonalities between all these attackers and the techniques that they use, but also to try to understand how to efficiently emulate all these TTPs, and of course also how they can be addressed from a defensive standpoint. And all these researches showed that various threat groups and actors have changed their Tradecrafts over the course of the years. So they're not reusing the same pieces of artifacts or tools over and over. They have been constantly evolving and developing new pieces of malicious software and payload all the time. So for this reason, we decided to focus specifically on activities conducted after the initial access or the execution phase. So basically the assumed breach scenario that I mentioned earlier, as this makes the most sense because usually attackers always find a way to gain code execution inside an environment. And this is especially true if we are talking about more advanced type of threat actors or nation-state sponsored cyber attacks. There's another important reason why we decided to focus specifically on the TTPs and not on a single piece of artifact or tool or command. And that is because those are very trivial for an attacker to modify, as we all know from the pyramid of pain. Whereas behavioral TTP are much harder for an attacker to change. And this is also proved by the fact that all these researches that I mentioned previously showed some sort of commonalities between the TTPs used by the various threat groups and actors. So, of course, each threat group or actor has its own specific set of tools and artifacts, but when we look at them from the point of view of the MITRE attack, we can definitely see the same range of techniques used for persistence, discovery, lateral movement, impact, and so on. And talking about the MITRE attack, so what we usually see in ransomware attacks, we see some form of enumeration. So for example, the enumeration of running processes on an endpoint, which is used both for detecting running processes related to defensive tools and software installed on a machine, but also to detect running office processes in order to kill them before starting any form of encryption of office documents. We see the enumeration of domain and network shares. We see several defensive agent techniques. So for example, various process injection techniques, but also the impairment and modification of services related to defensive tools installed on the machine. We see several persistence techniques. So for example, scheduled tasks or registry run keys. And then of course, we see a lot of impact techniques related to the encryption of files, but also to the impairment of recovery, so the enumeration and deletion of shadow copies. And then of course, we also see a lot of other techniques that may be specific to a particular threat group or actor. And all these TTPs that we gathered for known threat groups, we then collected those into an Excel file where they were then mapped with the relevant MITRE technique and linked to their phases. So there's a one-to-one link between the technique and the related MITRE phase. So persistence, defensivation, credential access, discovery impact, and so on. But also with the group and subgroup of techniques and the ID that MITRE assigned to them. The idea is to make this Excel file grow as much as possible. So including all the TTPs that we are seeing being used in the wild by ransomware attackers. So we hope to make this a collaborative effort in order to then being able to implement as much as possible into the tool itself. And of course, all these TTPs are then reused to emulate specific threat actors or groups. So for example, Ryuk or Maze. Of course, we know that nowadays, almost every organization has some sort of AV or EDR solution that is somehow efficient into detecting and blocking ransomware attacks on an endpoint. But the thing here is that the main risk is posed by the most advanced type of threat actor. So of course we are trying, this is the reason why we try to collect various TTPs for threat groups and actors that go beyond the usual process of simply encrypting the data, which is something that we usually see in less sophisticated type of attacks. And there's also another problem related to common anti-malware AVs and EDR solution, and is that most of the times this type of tools focuses on static detection. So a database of common hash artifacts, tools or commands, and those, as we recall from the pyramid of pain, are very easy for an attacker to change. And again, especially if we are talking about advanced persistent threats or nation-state sponsored cyber attacks, which are the one that poses the highest risk for organizations and the ones that have been the focus of the emulation of the attacks inside the development of our tool. So if we take, for example, Active Directory enumeration, just as an example, there are a lot of ways that you can use to perform Active Directory enumerations. So focusing on every single tool or technique that you can use to achieve that objective, it's definitely not feasible and not a very smart approach. A much better approach, which is essentially what we try to do, will be to instead focus on the dynamic behaviors and patterns. So if we can somehow shift the focus to identifying anomalous behavior, then we can develop a much more mature security posture. And of course, this is not to say that this type of tools are useless. It's just that when it comes to more advanced type of attacks, they cannot be seen as the single line of defense. So if we take into consideration the most catastrophic security incidents that happened in relation to ransomware attacks, they happen to organizations that still had some form of protection. But when we emulate as much as possible what a real life attacker is doing, and we try to build defensive mechanisms based around those behavior, then we have a much better chance to, first of all, detect this type of security incidents, to react to them, and last but not least, to also fully leverage the potential of all these existing defensive technologies like AVs, EDRs, and so on. And this is a perfect example of what I just talked about. This is a screenshot of a whitelist of artifacts of for a known EDR vendor, which is basically there by default upon installation. And it's basically a whitelist of artifacts for the configuration of the PowerShell.exe process inside the registry. So what is Fransom, how it was built, and what are the functionalities that it provides? Well, Fransom is a simple executable that provides a series of options to emulate specific ransomware TTPs. And as I mentioned previously, it's meant to be run from the point of view of a compromised endpoint to assess and measure the effectiveness of existing defensive technologies. We chose to develop the tool in .NET for a couple of reasons. First of all, because it allows the implementation of several techniques in a very easy and smooth way. And the other important reason is because of the compatibility with existing frameworks and tools that are usually leveraged in this field. So I'm talking about all the other Sharp tools like SharpUp, SharpRTP, SharpShare, SharpView, and so on. But also functionalities like ExecuteAssembly of CobraStrikes or any other C2 framework for that matter that allows the execution of C#.NET assemblies in memory. And of course, also the PowerShell capability of working with .NET Reflection. When we developed the tool initially, it was a simple executable that, as I said, was meant to run through the command line by specifying the option related to the technique. Then we modified it to also include an interactive shell in order to be able to execute it in memory, but also to have this sort of command line prompt feel where we can basically work with the functions and options that the tool offers inside the context of the executable itself. So without having to call it each time that we wanted to execute something different. Some of the techniques that we implemented are well known by now by antivirus solutions like Windows Defenders. So for example, the dumping of the LSAS process memory. So what we did in order to bypass that was to use a project like Defender Check, which basically identifies the piece of code that gets flagged by malicious. And then just by making some slight changes to it, we are able to bypass the detection by Defender and making it completely undetectable. And again, this shows why a lot of these tools cannot be used as a single line of defense, especially if they rely on static detection mechanisms. Like in this case, it just becomes very easy to get around that. And this is an example of Defender Check in action against Sharp Dump. So basically here we see that Defender initially identifies the binary as malicious, and Defender Check is able to quickly identify the piece of code that triggers the detection. So basically by just commenting out the offending lines, then we are able to make the tool undetectable by Defender. Yet this was not enough to get around some of the most advanced DDR solutions. So in order to not having to fight each time with every piece of signature and having to change the code here and there, what we then decided to do was to develop our own custom stager and dropper. Of course, the focus has always been on the emulation of ransomware attacks, not on defensive evasion or obfuscation, so we didn't go crazy with that. Yet we thought that developing this custom stager or dropper was a pretty neat thing to do, because if we think about the way that APT operates, we never really see a single piece of executable or artifact. We usually always see some form of stager or dropper that download the actual payload and then proceed to execute it. And as of now, the stager that we implemented, we can use it to run the fransom tool without existing trigger AVs and EDRs. The implementation uses C++ modified for common language infrastructure, which is basically a way to mix both native and managed code inside a single binary. And we used a mixed assembly dropper projects from GitHub as the main source of inspiration for our development. And as I mentioned, so far, we have been able to use it to invoke the fransom tool assembly memory without triggering the DDRs and AVs that we encountered during our engagements. We developed fransom in such a way that it is possible to execute it in several different ways. So the first one is the one I just mentioned. So the execution through a stager or dropper that basically fetch it from a remote location, decrypts it, execute it in memory, and it also executes, of course, the function that we pass and that we want fransom to execute. The other option is to just basically the standard way, which is the one I talked at the beginning. So basically just running the fransom executable through the command line by passing the option related to the technique that we want to execute. And then, of course, we can use a function like the ExecuteAssembly function of CobraStrike in order to load it and execute it in memory. This is a list of the various TTPs that we have currently implemented into fransom. And as I said, we hope to expand this list to also include other TTPs as they are seen and used in the wild. But what we have right now is the addition of the executable to the registry run key in order to achieve persistence on the local endpoint. We have several defensive evasion techniques, so different process injection methods like APC injection, thread hijacking, a remote thread injection, and also the injection of an external DLL library. We have the removal of Windows events logs on the endpoint where fransom is ran. We have the dumping of the LSAS process memory in order to access credentials offline with Mimikatz. We have several enumeration techniques. So we have enumeration techniques specific to the endpoint where fransom is run. So the enumeration of files and folders under the user profile and also mounted network shares and drives. But we also have Active Directory specific enumeration techniques. So the enumeration of the main shares, users, groups, computers, and trusts. We also have a bunch of impact techniques. We have the encryption of files and folders stored under the user profiles and also on mounted network shares and drives. We also have the enumeration and deletion of shadow copies, and we have the kill of running office processes. Related to the encryption, we have actually implemented that into two different ways. So one is the standard procedure of encrypting files and folders stored under the user profile or mounted network shares, as I said, with the relevant decryption technique in order to be able to recover the original data. But we also have another option, which is basically to automatically create a folder under the user profile desktop that will generate random files with dummy content and basically will delete the original version of those. And this is used to fully emulate the typical ransomware attack behavior. And in relation to this last technique I mentioned, there's also an option to automatically clean up the temporary files that are generated during the execution of this technique in order to not have to go there and delete all of those manually by hand. So now there are some videos that show some of the Weighin techniques that you can use to run fransom, and these are very short videos, a few seconds for each. The idea is just to give an idea of how you can execute the tool in different contexts. So the first example is the execution through the stager. So basically here, the stager is invoked through the command line, which in turn will download, decrypt, and execute the fransom assembly memory. And we specify the option to perform process injection through APC. So what that means is that a new notepad.exe process will be created, and that notepad.exe process will in turn spawn a calc.exe payload, just as an example. So we can see here we are invoking the dropper through the command line. We specify the option to perform the APC injection. And basically here, now the dropper is retrieving the fransom payload, and the notepad.exe process is executed, and then also the calc.exe payload in turn. Then the second example shows the interactive shell. So here we are running fransom tool directly through the command line, and we are specifying the option to enter the interactive shell. And from there, we can basically invoke all the functions that the tool offers inside the context of the executable itself, all the functions that we would usually call as arguments. In this specific case, we are just showing the help menu to list all the options that are available for the tool. So here we are basing again to the command line, we are invoking the fransom assembly, and we specify the option to enter the interactive shell. This is the look of the interactive prompt. And this is basically the list of commands that are possible to execute inside the context of the executable itself, but also by passing the related argument through the command line. So as we can see, we have a bunch of enumeration techniques. We have the related encryption and decryption techniques. We have the cleanup techniques in order to remove temporary files generated by the various techniques. We have the process injection techniques. We have the persistence techniques and all the other Active Directory specific enumeration techniques. Then we have the execution of the tool through the ExecuteAssembly function of CobraStrike. I'm sure most of you are familiar with CobraStrike, but just very briefly, CobraStrike is a command and control framework that works by controlling endpoint with what are called beacons. And the ExecuteAssembly function allows us to use a beacon to inject C#.NET assembly into a managed process. So what happens here is that we are invoking the fransom assembly through the ExecuteAssembly function of CobraStrike by using a beacon, a pre-existing CobraStrike beacon that is running on the endpoint. And we specify the option to enumerate shadow copies that are present on the host. So here we are in CobraStrike. We are using the ExecuteAssembly function. We specify the fransom assembly, and we specify the option related to the enumeration of the shadow copies. Basically, this will return the list of shadow copies that are present on the host. In this case, it will be just one, basically, because there's only one shadow copy present on this host. And then as the last demo, here we are performing remote thread injection, where we are basically inject a CobraStrike beacon payload. So this is pretty much straightforward. We are using this to obtain a new beacon on an endpoint where we are running fransom. So as we see here, we are executing fransom again through the command line. We pass the option to perform remote thread injection, and we specify the ID of the process where we want to inject the payload of the beacon. And sure enough, we get a new beacon back on CobraStrike. So we have collected the results of our tests against the AVs and ADRs that we encountered during our engagements. So we have Palo Alto Cortex XDR, we have Microsoft Defender for Endpoint, we have Sentinel-1, and we have F-Secure RDS. And the results were pretty interesting. Something that is worth mentioning here before diving into the results is that all these type of tools focus heavily on the initial access or execution phase of the MITRE attack. And we don't focus on that part because, as I mentioned previously, we assume that the most advanced type of threat actor will find a way in any way. That being said, it's still quite impressive to see how some of the TTPs that we'll look at in a moment that have been known for years by now are still not detected. Especially when we consider that this type of tools a lot of times are being sold as next-gen AI-powered solution. But the reality is actually that a lot of them still heavily rely on old static detection mechanisms. So, of course, again, this is the reason why they cannot be considered as the single line of defense. Another important problem is that a lot of times these type of tools are massively misconfigured. So that's the reason why we think that focusing on TTPs and dynamic behavior is a much better approach when we try to develop a defensive mechanism around all these type of threats. One other important thing to mention here is the difference between detections and escalation. So in the context of F-Secure RDS, which is basically a managed DDR, we are talking about escalation. So escalation to the customers for the techniques and tests that we executed. Whereas for unmanaged DDRs, we are talking about detections. And we did not build any sort of lab or environment where we executed those tests against these AVs and EDRs. So these are results that were taken from our engagements from our clients and customers. So of course, each customer has its own environment with its setting and configurations. And it's important to keep this in mind when we look at the results of this test, because this type of tests were all executed into different conditions and different environments. But for the persistence TTPs, none of them were able to identify them so far. With defense evasion, we ran 3 different process injection techniques. So APC injection, thread hijacking, and remote thread injection. And we only had Sentinel-1 blocking one specific process injection technique, which is the APC one. So that means that basically the thread hijacking and remote thread injection techniques went undetected by Sentinel-1 as well. With credential access and discovery TTPs, those were also not detected by any of these tools. We also need to mention that with F-Secure RDS, we only executed 3 out of 8 of the discovery TTPs. And for the impact techniques, we were basically blocked by Cortex XDR, Sentinel-1, and F-Secure RDS when we attempted to delete the shadow copies, but not by the vendor. Whereas for the encryption for files and folders stored under the user profile, we were only blocked by the vendor. And the very interesting thing here is that the vendor identified the attempt of encrypting files and folders as a generic CobraStrike detection, which was really weird because we didn't use at all CobraStrike or any form of beacon when we ran this test. So we were basically just invoking the executable through the command line by passing the option to encrypting files and folders. So there was no CobraStrike or beacon involved. And this was really weird. And I kind of missed the logic of why that is. So what are the major key takeaways from all the things that we discussed? Ransomware attacks continues to pose a major threat for organizations, and the number of this type of attacks is not going to decrease anytime soon, unfortunately. Security teams responsible for the overall security of an organization should focus their tests on the detection and response capabilities in order to be prepared when this type of attacks happen in real life. And in order to automate the emulation of all these TTPs used by ransomware threat groups and attackers, we decided to develop an open source tool, which we named Fransom, which helps assess the and measure the effectiveness of existing defensive technologies inside an organization. We also gathered a series of links of the things that we have discussed. So there's a link to the Fransom tool repo on GitHub, where you can also find the Excel with the TTPs that we have collected. But there's also a link to a blog post that we have been writing about the subject that you can find at blog.fractal.fi. And the blog post goes into much more detail about all the things that I've been basically talking about. So if everybody wants to dive in a little bit more, that is definitely the best reference for it. So that is all I have for you. Would like to thank our clients for trusting us enough to test the tool and the techniques that were discussed, and also for trusting us to release the results of the tests that we have conducted. And of course, thank you all for having me here and listening. And if at some point there are questions or comments, feel free to reach out.
Thank you very much, Francesco. That was an awesome talk. We indeed have questions for you, since the talk was really good. So you might have answered some of these already during the talk, but let's go through them still. Do you use automated unit integration and end-to-end testing with your development?
This is something that we implemented recently, actually. So when we started the development of the tool, there was nothing so crazy or complex, because the initial development of this tool was very, very basic. So it was just a simple project in Visual Studio and nothing like spectacular. But then later we also implemented all these sorts of pipeline in a DevOps, style that is basically that allows us to also use unit integration and automatically build the project upon all the various requests and pull. And this is also, I take the chance here to mention that we hope to, as I mentioned, make this a collaborative effort. So every sort of issue or PR, feel free to push those on GitHub and we'll have a look, and we hope to also implement as much as possible into this tool.
Alrighty, what's the wildest way your fransom or its beta versions has gone haywire?
Well, it never actually went haywire because it's not supposed to go haywire. So the way that this tool is designed is to test specific techniques that are related to ransomware TTPs. So it's not like a chaos monkey or anarchy type of tool that can release the craziness inside an environment. Also because if we would have done that, then probably at this point we would have no customers or clients. So I guess the most important thing to consider here is the purpose of the development of this tool, which is, as I mentioned, to test specific TTPs and patterns. So when we are executing specific TTPs and patterns, we are just executing one specific technique. So there's not like an automation of tools or techniques that can destroy databases in production, so to speak. That's my point.
So are you worried that the developed tool could be used and weaponized by ransomware gangs and criminals?
No, absolutely not. And there are several reasons why this is my answer. And first of all, as I mentioned, the purpose of this tool is to actually emulate various TTPs and patterns used by ransomware attackers. It's not to encrypt the data, and or rather, it's not to just encrypt the data and ask a ransom to a company. So if you want to use this tool to as a ransomware in order to do malicious things, you will find out that you basically end up rewriting an entirely different tool, because this tool does not include all the initial access and execution techniques, which are basically an fundamental part of all the ransomware attacks. There's no delivery mechanisms, there's no privilege escalation techniques. So basically, you will end up writing an entirely different tool built for for a totally different purpose. We also need to consider here that for every encryption technique, there's the related decryption technique that allows to get back the access to their data. And the encryption key is actually hard-coded into the source code itself, which is basically like crap OPSEC if we are talking about offensive operation and stuff. But we did it because we don't really care. I mean, our purpose is not to do malicious behavior. Our purpose is to actually measure and test the effectiveness of the defensive technologies inside an organization. So we don't really care if the encryption key is actually hard-coded inside the source code itself.
Alrighty. How are you taking into account the increasing cloud infra use with less and less inner networks, like, for example, cloud servers and cloud ADs, Azure AD, and so on?
That's actually a very interesting question, and it's actually at the core of the main reason why I decided to focus on this two different fields, which are basically the offensive side of cyber and the cloud security. And it's because I think that the InfoSec world is somehow lagging behind when it comes to that specific topic. So when we talk about the InfoSec community and the security world related to penetration testing, red teaming, and all this type of assessment and testing activities, we still see a lot of focus on old legacy on-premises environment. It seems almost as the cloud adoption has been very slow in general, but also in the cybersecurity world. So it's hard to find technologies, process, but also people skilled in the field of cloud security and how to assess and test the cloud services on the major cloud services provider. So that's the reason why I decided to focus on this topic and try to develop, exploring, as I mentioned, different ways of applying all this type of test and assessment to the cloud, trying to research what people are doing in order to test the security, what are the process and methodologies to conducting penetration testing activities, red teaming exercises into the Azure-ready environment. So we definitely see, for example, companies using more and more Active Directory infrastructure on Azure environments. But then, of course, when they, for example, are conducting red teaming activities, you have people that are focusing specifically on the on-premise Active Directory environment, and they're not focusing on things like the synchronization between the Azure Active Directory and the on-premise Active Directory, all the, for example, the tokens and all this related stuff that are specific to the integration between on-premise and cloud Active Directory. So this was kind of a very articulated answer, but hopefully it answers the question.
All right. Do you think purple teaming could be used for developing offensive capabilities as well? It's usually considered as developing the blue team stuff, detecting the red team operations. So do you think it could be other way around as well?
Yes, absolutely. Related to that, there's an excellent topic, well, actually an excellent talk by I think his name is William Schroeder, but basically Harmjoy, which basically everybody in the offensive world knows. He has developed a lot of this offensive sharp and PowerShell stuff. He made this talk, I don't remember what was the convention, but basically he had this extensive talk on how to create a DevOps pipeline in relation to purple teaming and offensive stuff. So basically it showed how they went on to the process of putting up Jenkins servers in order to build automatically tools like the various sharp releases, like sharp RDP. Actually, they kind of went crazy. They went really insane because they implemented like things like OPSEC checks on the source code, triggers on the CobraStrike and on the various notification chats. So I highly recommend to go and check that talk because it's amazing, and it actually shows how we can actually shift all this development process, all these methodologies that are usually applied to development of tools in general, or maybe the development of defensive tools. We can also apply those for the development of the offensive stuff.
Alrighty, there was also questions about the licensing fee for the tool before you told it's open source, but I skipped those ones, and Jyrki Huhta actually told on the stream chat as well that you will be surprised when you hear the price. Yeah, well, there is one more question, and it's about the code. Why are there no comments in the code?
Yeah, I cannot comment on that. It's related to that. No, but actually we try to, the reason why there are no comments is because, as I mentioned, this type of tool was developed with the intention of emulate ransomware attacks lifecycle and the implementation of various TTPs. It's not meant to be like an extensive framework or something that will integrate like multiple classes or something like that. Of course, we hope to see the tool grow as much as possible, but we are not like expecting like a crazy big project, including several libraries and dependencies. So that's the reason why we didn't really include a lot of documentation of code. The main idea is that when you want to implement a technique inside the tool itself, the way that the tool is structured, it becomes kind of easy to figure out what to do. I mean, building a documentation around a project that is so small in a way, even though it offers a lot of functionalities, it's probably not the best use of our time, so to say.
All right. Thank you very much, Francesco, for being
Thank
tonight
you.
with us and having this great talk. And before we move on, we will have, before we end tonight's stream, we will have a few-minute break and then the closing words. So stay tuned for that. And thanks once again, Fractal and Francesco.
Thank you. Thank you for having me here.